A conical filter is 30 centimeters in base radius and 40 centimeters high. Liquid escapes through the filter at the rate of 12 centimeters cubed per second. How fast is the level of the liquid changing when the depth of the liquid is 10 centimeters? Leave your answer in terms of pi. So if it's a conical filter, from the side it's going to look like a triangle. And we're being told that the height is 40 centimeters and that the base radius is 30 centimeters, and that gives us proportions for any level of liquid in here because we can just use similar triangles. So let's say that the level of the liquid at some stage is H and that this is R. Then from these proportions we can see that R is going to be 3/4 of H. Now let's look at information given to us. So we're given that dV dt is -12, negative because this liquid is leaving the filter, so the volume is decreasing, and that's why dV dt is negative. We're required to find dH dt when H is equal to 10. Now, the volume of a cone is given by 1/3 pi r squared h. So the volume of this liquid is given by this. But we know that r is equal to this for this particular cone. So that's 1/3 pi times 3h over 4 squared times h. So we need to tidy that one up. So that's going to be pi 9h squared over 16 times h. So this will cancel down with that. And we're going to get 3 pi h cubed over 16. Now we want dH dt. So dH dt could be given to us by dH dV times dV dt. Now, dV dH we can work out. That's going to be 9 pi h squared over 16. So dH dV is just going to be 16 over 9 pi h squared. So dH dt is going to be 16 over 9 pi h squared times dV dt, which we know is -12. Do some cancelling here. 3 goes in here 3 times and in here 4 times. 16 times 4 is 64, so that's going to be -64 over 3 pi h squared. And we want this when h is 10, so dH dt when h is 10. So that's going to be -64 over 300 pi. And that cancels down to -16 over 75 pi and that would be in centimeters per second.